Hello student, welcome to today's session. So in today's session we are going to look at reactivity series. By the way, this is just the session for testing our system, and of course just to make sure that you see how our classes intend to be. So this lesson is basically on reactivity series. Reactivity series. Okay, so more sessions will be conducted via online, and this is how you expect them to be. All right, so let's get started. Definition: reactivity series is simply the list of metals arranged in order of their ability to displace other metals. Okay, so now one thing that we need to consider is that these metals actually react in different ways. Right? We've got the most reactive metals as well as the least reactive metals. Now this reactivity series basically gives us the hint, or it will show us how these metals are actually reactive toward acids, towards water, and of course steam at large. So we are saying this is the list, this is the list, this is the list of metals, this is the list of metals arranged in order, okay, in order of their ability to displace other metals, okay, metals from their compounds. So this list actually, it just tells you that the element which is higher than the other is capable of displacing it in a case where two of those metals are actually reacting, okay, in different compounds. So now this concept of reactivity series will help us to understand what we are calling as extraction of metals as well as redox reactions. Okay, so it is very crucial. It is very crucial. So we are saying it is very crucial in understanding concepts like redox reactions as well as extractions of metal. So it is very crucial. When we say crucial, we mean it is also like important, right? It is the important part in understanding for understanding concepts like redox reactions, understanding redox reactions, as well as concepts like extractions of metals. So in order to perform to perfectly perform extraction, or how in order for us to extract the metal perfectly, we first have to understand this concept of reactivity series, so extraction of metals. Okay, hope you are following. So now, what are we trying to understand in this case? One thing that you are going to notice here is that the most reactive metal, right? Most reactive metal is arranged first, or is put on top, and the least reactive metal is put on the bottom. Or we can simply say most metals, or rather let's just say metals are arranged from most reactive to least reactive. Is that okay? So now what we mean by that is that we are going to have a case where you are going to see something like this, where you are going to have a list dropping like that, where the most reactive metal, most reactive, will be on top here, and you expect to see the least reactive metal here. So that is the whole scenario of reactivity series. So the one that will be on top is the most reactive metal, and the one that will be on the bottom here will be the least reactive metal. So now what you should understand further is that the order of reactivity can be determined by the reaction of metal with water, steam, or acid. So we are going to determine this order based on how these metals react with water, how these metals react with steam, and how they react with acid. So we are saying the order is determined by the reaction of the metals, by the reaction of these metals with either, so with water, okay, steam of course, and acids. So the way these metals react with steam, water, and acid actually determines how they are arranged in this reactivity series. So now what you observe is that the metal, for example, if a metal is here, suppose we have calcium here, of which I'm going to give you, and we have copper here, and then suppose let's say potassium hydroxide is reacting with copper oxide. So now this other point is saying that the metal which is on top here, right, is capable of displacing this metal which is below it. So in this case, if you look at potassium, and where copper is, you can see that potassium is on top, calcium is below there. So we are saying the metal higher up in the series will displace the one below from the aqueous solution. Suppose this is the aqueous solution that we have. So what we are saying that this potassium, because it is higher in the reactivity, it will displace this copper which we have in this context here. Are you able to see? So we are saying if the metal higher up in the series, the metal higher up in the series is capable of displacing the one below in its aqueous solution. So these which are reacting, this one has to be in aqueous, also this one has to be in aqueous. So we are saying if they are both in aqueous state, the metal which is above the other one is capable of being capable of displacing the one below it. So this is the whole point of the reactivity series. So when you see a metal up and then the reactivity is dropping, the lower the reactivity, the more the more it becomes unreactive. So now in our next video, we are now going to look at how these metals are arranged and which one is the most reactive metal and which one is the least reactive metal. And dear and deaf students, You are all welcome to this platform. Let's explore it together. Together we can do it. Sharp, sharp.